Okay, everybody. Well, thank you so much for joining tonight's ASHRAE Illinois Chapter technical meeting. We'll be talking about refrigerants, both for today and tomorrow's solutions this evening. And I'm one of your hosts, Mitchell Kelly, and here's my other co-host, Kevin Reichert. We are the ASHRAE Illinois Chapter CTTC co-chairs. If you have any feedback regarding tonight's meeting or ideas for future meetings, please reach out to us at the email listed here, cttc@illinoisashray.org. Brady Greer, who's seated over here, is going to be, leading in spirit tonight's presentation. He's done a lot of work to get our two presenters set up for tonight, who we're very, very excited about, both from Daikin Applied as well as Trane Technologies. As always, if you guys would like to come to the meetings in person, we are hosting all of these hybrid until we can hold them permanently in person again. We do have food and beverage service available if you guys so choose to join. I guess, Kevin, with that, next slide, buddy. So a quick agenda for tonight, a couple news and notes before we get started. We do have a region refrigerant presentation given on Thursday by Mr. Steve Kujack, who is going to be with us tonight for a little bit of a preview, but he's going to be giving a very interesting presentation with an emphasis on flammability, refrigerants and refrigerant safety on Thursday. We also have the Young Engineers and ASHRAE Trolley happening this Friday. For more information, please reach out to your YEA contact. We also have the ASHRAE new children's book that just got recently published called Lucy's Engineering Adventure that we're all very, very excited about. Once we have a couple published copies, we're going to be raffling them off at the ASHRAE holiday party. Nice little segue there. Thank you very much. That's going to be happening on December 7th. More details to follow on that. Now with that, we're going to get started tonight with a couple of introduction presentations and position overviews from our two keynote speakers this evening, both Steve Kujack with Trane Technologies, as well as Phillip Johnston with Daikin Applied. Then after that, we're going to have a question and answer session where we have a couple of about 10 or 15 questions that we have received in advance that we're going to alternate speakers with them taking the lead on answering, and then the other will have an opportunity to answer as well, or if they have anything else to add, they can add it. But throughout the presentation today, if you could please type your questions into the chat room, we'll be sure to add those questions to that question and answer session at the end. With that, and without further ado, we will move on to Mr. Steve Kujack of Trane Technologies for his, position statement and introduction. Steve, take it away. We have you on mute, Steve. Sorry, sir.
Hello, everyone. Sorry, I was on mute.
We got you.
And I'm figuring out the share again. All right. Well, I hope everybody's having a great evening. It was a beautiful day here in La Crosse, Wisconsin. I actually went golfing and skipped out of work because you don't get too many days where it's going to be 55 anymore. So tonight we're going to talk a little bit about the future of refrigerants. Sometimes I call this the transition has begun, because it's begun many years ago with the introduction of new lower GWP global warming refrigerants. So let's just get started into this. So what are we up against here? We're up against some regulations around HFCs and fluorinated gases, which have higher GWPs. And back in 2016, the world got together and agreed to an amendment to the Montreal Protocol. And remember, the Montreal Protocol is an ozone depletion treaty, but they amended to add HFCs and do global warming reduction. And so this was done in Kangali, and so now it's called the Kangali Amendment. So the process works pretty straightforward. This is a phase down of global warming potential refrigerants. So we establish a baseline, and usually based on the country, individual countries, it's around 2,000 GWP, and then we phase down to a lower global warming potential. And so what was agreed to, and I'll show you here in a slide, is there's a couple different agreements or laws going on around the world. The first one is the European F-gas law, which looks like this, and this is their phase down schedule. You look at developed countries around Kangali, this is the phase down schedule that was agreed to. So we slowly reduce the global warming potential of the refrigerants that are in the marketplace or introduced into new equipment as time goes on. And then in the developing world, there are a couple different other agreements that we looked at for phasing down in the future. Now, the developing countries will likely be pulled forward as technology develops. So this is a phase down. So all refrigerants are available for use for blending and mixing. And it seems more complex, but as technology develops and the products are out there with new lower global warming refrigerants, it becomes pretty straightforward in adoption. So let's take a closer look at the United States here, or in the development countries. And so right now we're supposed to, most developed countries have in place maybe a 10% phase down. The EPA, and we'll talk about this here in a second, the EPA issued rules in October around the USA AIM Act, or the American Manufacturing Act, which was enacted in December of last year. So this is really moving quickly that we're going to be in compliance with Kangali. And so EPA issued last week the 10 piece of this. And so in a couple of years, we're going to have to be down 40%, and then further out, working our way down. You can see I put some GWP levels to this to give people some calibration of if you're using a solution or a solution is offered, of how sustainable that might be in the future, potentially. So this is how and when the phase down is going to occur. So in April of this year, in accordance with the AIM Act, they created the HFC production and consumption schedule. And then October 1st and 5th, we had some allocation rules for the 10% reduction for 22 and 23. Now, believe it or not, most of the industry, with cars going to 1234 YF in a lot of cases, and foams already implemented into lower GWP fluids, the 10% reduction is going to be nothing but nobody will feel the effects of that. The real effects will occur in 2024 with the 40% reduction. And we expect a rule for that next year. Now, a couple of more nuances to what was issued here. The baseline here in the United States was set with the 3 highest production years between 2011 and 2019, which is good because that'd be the highest baseline possible. So then as a phase down occurs, it's much more gentle in that case. One of the big things that people aren't aware of that have been issued in this rule was the ban of non-refillable cylinders by 2027. So that's going to start beginning or roughly in about 2025 and then be phased in. And so the disposal cans that you see today that people use in their trucks for service equipment is going away. You're going to have refillable cylinders, and then those are going to be recycled back and refilled. So that's going to require tracking of refrigerants. And so they put in place a QR codes for refrigerants. So as refrigerants are sold, they know and track their use in a chain of custody type of thing. Now, it was interesting just a couple of weeks ago also, they granted the petitions that a number of organizations issued to the EPA to guide them on what they thought was acceptable phase down. And so a number of organizations, AHRI, AHAM, the EIA, the NRDC, they granted these petitions so they can use them in their rulemaking. And you can find all this information on the EPA site with the link here. So what were in these petitions, right? So what we're seeing here is a kind of a quick summary of the petitions. So AHRI and AHAM, you know, you're looking at air conditioning chillers are going to be phased down January 1st, 2024. That was the proposal. We'll see if the EPA accepts that. And then unitary and VRF equipment at 2 different times, 2025, January 1st, and January 1st, 2026. And these are all going to be less than 750 GWP for all products. Now, there's a number of candidates out there, R32 and R450, 4B, and R466A, which meet these requirements and technology being developed. So there is technology available. It's just a matter of adoption of the standards and codes, and that's why the dates are where they're at, is the standards and codes need time to regulate in the changes for the product standards, application standards, and then finally the building codes. Now, racks are very simple. You know, they're a little sooner. So any window air conditioner type stuff with no electric heat, they petition for 2023, 2024 with electric heat. And this is really about compliance and getting these things tested and certified. And then we look at refrigeration. It's much more complex what AHRI put together because the technology there is not as certain. about what GWP you can get to and what temperatures and what ranges of operating map you can get to. But they laid out a schedule here that allow the 40 to 60% phase down of these fluids. So how do you select a refrigerant? And people have listened to my talks before. We talk about the sustainability selection. So, you know, the social economics, I'm really big on that, and in the environment. And how do we balance that to get a sustainable solution? So the replacement challenge is we have all these requirements around the social economics and the environmental regulations. And then we have the core items around safety, the direct GWP of the refrigerant, the efficiency, which is the indirect, how much it costs for the transition, intellectual property, and product sustainability. You know, and we look at this, and then we have all the equipment operational things we have to understand, and all the regulatory compliance around toxicity and flammability. So in the last transition, the biggest challenge we had is we had refrigerants. We just didn't have lubricants that were compatible with the refrigerants. And so we were waiting on lubricant development in most cases so that we can enable the transition. And in this case, I just mentioned earlier, flammability is our primary challenge. And so this Thursday, I'm going to put a plug in myself here, is we're going to talk about flammable refrigerants for dummies. And the reason why I use this, title for my talk is, you know, when you're using a non-flammable refrigerant or ASHRAE class 1 refrigerant, it's pretty straightforward. You can handle it. You can have ignition sources. You can have a leak. It can be in the environment. When you have flammable refrigerants, you have to think a lot more about it. So you're going to have to create a number of different things. You have to internalize to yourself about how you're going to handle these going in the future. So here's our toolbox of various different refrigerants that have made it this far. To look at, you know, and so the ASHRAE classifications are on each one of these along with the GWP. You can see we have a lot of A2Ls, or, you know, low toxicity with a lower flammability classification, the new classification 2L. And so a lot of these low GWP refrigerants require the handling of them or blending of them to either make them non-flammable class 1 or change their flammability characteristics or use them as is. So this is the main challenge, and we'll talk about this Thursday as well. So if you look at this in the terms of GWP on the left-hand axis and compressor displacement along with the various compressor products at the top, you quickly realize that you have a flammable region where you can have candidates that have lower GWP and flammable, but there's a wide assortment of non-flammable lower GWP fluids as well. And then there's a section where there's ultra low, especially in the lower pressure areas. The replacements for 123 and 245 FA, you can get to GWPs of less than 10 and be non-flammable. And those refrigerants are being adopted today, and along with these other lower GWP fluids, non-flammable, because the standards and codes are already in place for non-flammable class 1 refrigerants. And so they're easy to adopt, easy to use, and the procedures and requirements are already in place for their handling. So a lot of people always ask me, oh, Steve, you know, these refrigerants in the past, we always talked about efficiency, and have there been efficiency impacts? It's interesting, in transitions, we actually can design in new stuff to make more equipment more efficient. Here's a chart of kW per ton versus time when refrigerants were introduced by Trane Technologies around 1233 ZD. You can see these were introduced quite a while ago. So there's been time for adoption over this period. Introduction of 514A, and then the phase out of 123 occurred last year. So you can see that the efficiency trend is downward, and it always has been downward because as technology develops, it's not the refrigerant, it's the hardware around it that drives the efficiency. Better compressor, better heat exchangers, better use of losses in the equipment, and handling of the refrigerant. So there's possible gains. There's really no impact on efficiency. So what actions should I take? Given all this information I'm throwing at you pretty quickly, low GWP refrigerant innovation is, an ongoing balance of the known science and proven technology. So we have a lot of proven technologies out there that get down to lower GWP. And there are some long-term ultra-low solutions available today that, are completely sustainable from the standpoint of they're going to meet the long-term requirements for the regulations as well, being high efficiency, and there can be non-flammable as well. So the guiding thing here is we got to find the safest, best balance enables the lowest emissions and the highest energy efficiency with the lowest life cycle cost is the key. So taking this balanced approach during regulatory uncertainty, and we're getting a lot more certain about regulatory stuff here, so that's kind of changed here. But the other thing you have to be aware of too is you need to maintain your existing installed equipment is a key too. So if people have read the book Project Drawdown, the number one action we could take today is to make sure we don't leak the refrigerant out in the first place and reduce those global high GHG impacts around the refrigerant. So maintaining the equipment, keeping it in integrity, running at high efficiency is the key to a sustainable future. So when we look at solutions and alternatives today, you know, like I said earlier, the non-flammables are easy to adopt at this point because the standards and codes are already in place for that. Flammable refrigerants are going to take some time here, 2024. We're going to see the building codes updated to handle those. So we have some longer term solutions already in place, 514A and 1233 ZDE. These are large applied water cooled products, you know, greater than 200 tons roughly is kind of dividing line there. We have some lower GWP interim solutions for, you know, 134A products. 513A is a classic one that's out there in the marketplace today. It's below 750 in GWP, so it's going to meet the 40 to 60% phase down steps. Longer term, we're going to have to be less than 150 probably, and it will be flammable likely. And so those solutions are going to be available once the building codes are updated and probably introduced in the marketplace as well. And then we have a number of interim solutions around unitary and residential applications for 410A. So we look at R32 and 454B, which are going to be the two candidates that are going to be in the marketplace. A lot of announcements have been made around those. These are interim solutions. The GWPs are, you know, 750 to 460. You know, you got to be below 750. I mean, they're flammable. I think we need more innovation to achieve the 85% we need, which gets you down to like 300 GWP. So if we, you know, I mean, the goal is going to be always drive the GWP down. And if we could have solutions that are all below 10, this is a no-brainer and we can meet our goals because we can use refrigerants in a more wide scale. So the average can continue to drop. So I always say, understand the facts, evaluate your options, plan and prepare to tomorrow. Here's some background stuff, the stuff I presented here. A couple of ASHRAE journal articles that myself and some colleagues have done. You can just go look them up. And today, too, there was an ASHRAE journal article. I led a discussion around flammable refrigerant standards. That's a really interesting discussion. I learned a lot as a moderator for that as the details become more and more evident to people. So here's a picture from my house, from my office, actually. You know, men continue to argue and nature acts. And that's the slogan I've been using for 3 or 4 years. And you can see at the COP26, men continue to argue, women continue to argue, but nature acts. So thank you very much.
Well, thank you very much, Steve. We really enjoyed that. There was a lot of great content throughout the presentation. Thank you for taking the time putting together. And I know the time structure was very tight there, so thank you for getting through it in a timely manner. Next up, we have Phillip Johnston with Daikin Applied Systems, who's going to be presenting his company's views and his, I guess, expertise on the subject as well. Phillip, take it away, sir.
I'm just trying to figure out how to share because I don't see the little orange box anymore. Oh, there it is. Not orange, wasn't there yet. Let's try that. All right, everybody. I'm going to keep it a little simpler. And one thing I want to say, Steve, thanks for that introduction. You covered a lot of the real important changes going on that are coming from the feds.
Phillip, we don't see your slides, sir. Sorry.
You don't?
Didn't want to let you get too ahead of yourself.
Thank you. Try something. You see anything yet?
No.
Not yet, sir.
Oh, that's not working. Worked earlier, so give me a second here. Window. That one.
There it is.
All right. My bad. I didn't hit that last button.
Oh, there we go.
How's that?
Perfect.
Okay. Back to, I think Steve did a really good job of giving a succinct overview of the federal regulations, the standards, and what's going on, and what needs to happen. In particular, I was glad about one bullet that a lot of people forget that he said, and that was stop leaking, stop the leaks. And that's what you can do now, because if we didn't have leaks, we wouldn't be talking about this. And there's too much of that going on. Nonetheless, we are. So I'm going to present a really an overview of who am I and who's Daikin, and get right to what are Daikin position points that are somewhat, but I won't get into the why. And if we get into the why, we can get into the why during the question section. So who am I? I'm that guy, but now with a beard. And I'm actually a chemical and biochemical engineer. My master's was in fluidized catalytic cracking. And it's funny, I did chemical and biochemical type work, environmental work, actually, a lot of environmental work for about 6 years. And then I did a big right-hand turn and got into air conditioning. And I am a professional engineer, grew up in Canada, so I'm licensed in Ontario. There's no way I'm ever giving up that licensure. I joined McQuay 20 years ago. We were acquired by Daikin 15 years ago, and did everything from purchasing and development activities and chillers, and then moved into a lot of development roles, product management, ultimately ran our water source, ground source, fan coil unit ventilator business. And then the last 2.5 years, I got tapped to work primarily as the general manager in charge of our low GWP transition at Daikin Applied Americas. With that, it had to bring a lot of learning for me, a lot of stuff that Steve has been doing for decades. I had to pick up, and the good thing is I get to rely a little bit on the chemistry background that I have. But as a chemical engineer, I'm no chemist, so but at least it helps in some of the conversations. When it comes to Daikin's environmental vision for 2050, in reality, the words may be different, but it's not an awful lot like what our entire industry has been pushing for some time. And all the major OEMs have similar objectives in mind. I think for Daikin, it's really all about being proactive about the environment and always thinking about the environment whenever we're making our decisions. And in particular, right now, it's a lot to do with climate change. Whether you're talking about creating super energy efficient air conditioning equipment because we know we need to, because a lot of the power that is generated around the world is still generated by burning of fossil fuels. And even if you were to move on into beneficial electrification, also called decarbonization, and if all of our power was from clean renewables, the grid is massively undersized. It needs to be updated. So it really matters about efficiency. So creating those sorts of products that can change the world. And I think our 2050 vision is a little bit inspiring to me in that we don't want to just be net zero for us as a company, what we do. We want to help all the building owners around the world become net zero. And we haven't figured it all out yet, but there's time. There's an awful lot of information out there. If you were to subscribe to the Cooling Post, for example, which publishes a lot of information that gets noted around the world, you would see over the last 9 years a complete ramp up of information about who's using what refrigerants and where are they using the refrigerants. And it can be rather confusing. And I think that's why some of the questions that were sent out to us shortly before 5 o'clock, you're asking, hey, what's going to replace for today? And it's a loaded question. And it's because you're going to see a mixed bag And you're going to see a mixed bag within companies. So if you look at this screen, you see Carrier picking 454B for ducted air conditioning, but they also had an announcement that they're going to use R32 for commercial scroll chillers. And you don't know, I mean, Carrier also partners with Toshiba and for VRF, I believe, or maybe they own them now, I don't remember. And I think they partner with Midea for mini splits. And clearly those companies are using R32 in other parts of the world. And then you've got, different chiller options, many different refrigerants to replace R134A, and a couple of different refrigerants that Steve mentioned to replace that are ultra low GWP refrigerant replacements for 123. So, and there's been information recently. So I think I can see why there's confusion. I think I was asked, how does Daikin, to prepare on this introduction, make their decision on refrigerants? And just like Steve said in his presentation, there's a whole lot of variables. I think in the end, when you sort through the variables, Daikin has a policy where they don't dictate to us at Daikin Applied Americas what refrigerants we're going to use. And in turn, Daikin self-admits globally that they want to be flexible in what refrigerants they're going to use, and they're willing to change their mind. What they want to have is the refrigerants that really are the best long-term throughout the total life cycle of the system. And that can be a different piece because you start seeing laws or regulations that everyone relates to global warming potential, and you hear GWP. And even if it, I'll point this out, the Kangali Amendment phase down is actually about total CO2 equivalency of every HFC used across every sector in the country in which we're dealing with. And so that phase down is actually phasing down CO2 equivalency. And I think the baseline that Steve mentioned is 293 million metric tons of CO2 equivalency. So if you see sectors that are using ultra low GWP refrigerants already, or if it's easier for certain sectors to move, it might relax it a little bit for some of the sectors that are struggling. And some of those sectors certainly might include the replacements for 410A that tend to be mildly flammable. So they're going to take a little bit of work, or maybe refrigeration. But I think Steve's right. There's going to be some potential movements right now, and then future transitions coming perhaps as early as 2030 or maybe a little bit later, depending on what we all figure out. Now, when it comes to all these variables, these are the four key ones that we're primarily concerned with. And safety is always a concern. If we weren't going to talk about that, then a professional engineer like me doesn't need to exist. Period, end of story. And you don't need chemists like Steve who can teach us, all about the chemistry of products. I think energy efficiency is absolutely critical. And I mentioned why earlier. We absolutely need to have super energy efficient equipment. There's a forecast that by 2050, there's going to be, I think it was 6 times as much air conditioning being used around the globe than right now. So when you think about it, think about the amount of power that's drawing. So we need to do better in terms of efficiency. Environmental impact is a really big deal, and that's from both the manufacturing and production of chemicals and raw materials right through to the decommissioning of equipment. And of course, cost effectiveness. We'd be silly not to talk about that. You can come up with ultra low GWP refrigerants, but if people can't afford them around the globe or even here in the United States, what's the point? And that's where the sustainability argument comes in. So I'd say these are the four core variables for the Daikin Group globally. And this is captured in a document that they've published online that you can go look up, as well as other details. When it comes to our choices, this is a global picture I snapped from a document that's online, and you can see that R32 is a big piece of it. When it comes to R32, it's an old refrigerant, been used for decades, and it's 50% of R410A. So theoretically, you only have to double production in order to use it. There's also some CO2 systems being used by Daikin in other parts of the world. Don't ask me about them. I don't know very much about them. In our commercial systems and VRF systems, we're committed to R32, at least for now. And that's what's in all of our development plans. When it comes to chillers and heat pump chillers, we're looking at a range of things, whether it's R32, 1234ZE, or even 1233ZD, and perhaps some other blends that come about with some of these base chemicals, as their backbone. Refrigeration systems, which is not my forte, but it's captured on this slide. A few different options here as well. And I don't know, I get asked a lot of these questions. Now, these were not in the questions you submitted, but these were the basis for a presentation that I gave last month, because I get these calls all the time being asked about, what's going on, what's the myth about GWP? And I hinted at some of it about CO2 equivalency, but there's more to that story. Talking about 454B versus R32, talking about a particular OEM field trialing R466A, and maybe a few other refrigerant choices on the chiller side of the spectrum. And depending where we go in the Q&A, I have some content I can share, but we can certainly talk about these as well, because it's all related. So just to summarize, when I think of Daikin here in the Americas, these are really kind of our proof points and our synopsis for us. So I created this just for this presentation. When it comes to low pressure centrifugal replacements, R514A, the big difference about this, it performs great, ultra low GWP, but it's still that higher toxicity class B. It's offered by one OEM. I think if your clients were accustomed to using 1, 2, 3, and they were quite happy with it, I don't know why they wouldn't be unhappy. The same would go with 514A. If they were happy there, they'd be happy now. I think Steve mentioned the A1 refrigerant, 1233ZD. A lot of those chillers are available today from JCI, Carrier, Trane. Very efficient, and I think it's the long-term solution in the large chiller platform. I really do. Super energy efficient, class A1. For a medium pressure replacement for 134A, pretty much every major chiller manufacturer has 513A as an option. It's slightly less efficient by 3, 4, 5% versus 134A. So that can hurt you climate-wise if you're not careful, but it is a lower GWP refrigerant. I don't remember the exact number. I'd have to grab a cheat sheet, but it's just below 600. So it's probably, kind of an interim step, like Steve was suggesting. We need to get better, need to get lower. And I think there are solutions being offered by several manufacturers with 515B, which is an A1 version of 1234ZE, I'll say. I think here in North America, those products will come a little bit later. There's probably technology work going on at all the major chiller manufacturers. What the chemical producer did is they squeezed in enough of a chemical into 1234ZE so they could pass the test to call 515B and A1. And you're seeing things going on like that where there's just enough of things squeezed in order to pass the test. As for a high pressure 410A replacement, the real reason we chose R32, if I was to summarize it, is it's the proven global alternative, 160 million units or more in operation around the world. No other components can say that. It's really easy to work with. It's available. Simply, it's available now everywhere, pretty much all around the world. It's more efficient across many applications, which ultimately leads to it being a really great choice for the environment. So hands down, it's tremendously great value. I will say though, it's really clear. Is one of the questions you pose, what's going to replace 410A? No matter what, it's going to be a mixed bag of R32 and 454B. Because when you look at the announcements that have been made by some other manufacturers that are not on this call, they've already announced the use of 454B. We've announced the use of R32. Carriers announced the R32 with their chillers. And then you also have all the over 40 manufacturers around the world that have VRF product and mini split products that they're going to be shipping into the United States at some point are already selling those products with R32. So I think it's just a hands down. There's going to be a mixed bag no matter what, no matter how you look at it. I think that's it for me.
Well, thank you very much for your position statements on it. That was very, very helpful. Let me pull up the question and answers that we have tallied thus far as we get into our next section, where we're going to alternate between the speakers, and I'm going to ask a question. I'm going to allow the first speaker to speak, and then the next speaker, if they have some sort of a, I guess, rebuttal or response or some sort of other, I guess, commentary, you're welcome to chime in. So the first question we have on here is, it seems like a new refrigerant is released to the market every month. What is the latest HVAC refrigerant, and why do we continue to need more on such a frequent basis? I guess we'll start with Steve.
Yeah, so I'm the chair of Standard 34, which puts the R in refrigerants. And so we get refrigerant applications all the time around creating new R refrigerants. I think right now we're with the refrigerants Phil and myself have presented, those are going to be the standard bearer refrigerants for now. People are always playing with intellectual property games where they're adding other refrigerants to other refrigerants to create a new R number. But the chemistry and the engineering behind it is pretty straightforward. I think the one thing that, and I'm writing a paper on this next year, so surprise. There's going to be a plethora of people who are going to come out with 410A drop-ins that are non-flammable, class 1, and they're starting to appear in 34 for classification, but there are not going to be any 410A drop-ins. There just isn't the chemistry available to allow to maintain capacity. What you're going to get is a lot of 407C type refrigerants, which are going to be off in capacity by 40–60%. So if there was a non-flammable lower GWP 410A alternative, we'd be using it. That is going to be, people are going to be creating classifications all over the place. It's interesting. Like Phil said, I've been at this for a while. I've been the director of refrigerant research at Trane for 10 years, and I always thought innovation would stop at some point, but innovation continues. And I think people are working on, can we make things more non-flammable? Can we make them lower GWP? And if we can get down below 10 for everything and be non-flammable, that would be a pipe dream. But every time I say that, somebody innovates and creates something new. But I think we have our strong candidates from now until 2030, and then we'll have more innovation, and then we'll phase down further in the areas of 404A equipment and 410A equipment. The solutions are available right now for 123 and 134A to get down to less than 10 GWP once we, especially for 134A, once we get the standards updated to handle class 2L refrigerants. So the biggest issue I see, though, and what's probably pushing this question, sorry for the long answer,
You're good.
is there's so many candidates that are, in the old days, we used to have a refrigerant that could cover the whole application range from small capacity to big capacity, say 410A, for example, or R22, for example. What we're going to see is a lot more fragmentation in products. So you're going to see hydrocarbons in small equipment. We already have it today. I have one in my house right now. Small dorm refrigerator, uses isobutane, works great. Small charge, less boom. So you're going to see this fragmentation occur throughout the marketplace. And so, like Phil said, you're going to see 32, you're going to 454B, you're going to see differentiation around GWP. That's not important. It's the right refrigerant for the right application at the right time. And at this point, we have candidates you can phase down with good solutions. And once we handle the 2L part and the flammable stuff, we're just going to continue to innovate and move forward, and people should have a lot of confidence in moving forward. Sorry.
No, excellent, Steve. Thank you for your response. Thank you for that. Philip, do you have anything to add on that point?
It's hard to add on to that. No, you're absolutely right. There's been a lot of announcements on refrigerants. Even at the Daikin Group, we have a chemicals division. I think we're the only OEM manufacturer that does. To a certain extent, that can be a blessing. Perhaps it can be a curse at other times. For me, it's the funny thing is there's nothing that we're using in this list of refrigerants that I said were Daikin in America's proof points that are coming from our chemical division. So it shows that they're using refrigerants and chemicals for many other industries. Now, let's just say Daikin Chemical came up with something. They're absolutely going to want to make it proprietary, just like Steve said. So when you said that earlier, you have a series of chemical producers that really are in a point where I don't remember, Steve, but I think in the allocations that are called production allocations in the AIM Act, and production allocations mean bulk production of HFC refrigerants here in the United States. I want to say there are only five major chemical producers that make up that roughly 300 million metric tons of CO2 equivalency. And they want to do the utmost to try and keep ahead of their competition. It's just the way it is. I think we as manufacturers try to do some of those things on our own. And sometimes also, they're also trying to make sure they're solving needs for their customers, or at least that's what we hope. The key will be, I don't see new chemistry being done. Maybe Steve can say otherwise, but there was even, NIST did a publication a few years back where I'm looking at the slide right now. I'm just not sure I want to share it or maybe
yeah, Mark McLinden did a nice job in NIST of looking at the universe.
Yeah,
but he put a little too many constraints on the universe. So some things he thought were toxic turned out not to be toxic. Some things that were more chemically unstable were not chemically unstable. So I think, as innovation occurs, people have to get that data, understand how it works, right? So, for example, we'll talk about your chemical division, right? They made an announcement around 1132E, right? High volume material used to make plastics. Nobody's looked at as a refrigerant. Got to do the tox testing. You got to do the stability testing. Oh, shock. Could be a refrigerant, right? Nobody looked at it, right? So, that innovation, can you blend it, right? So that innovation, I think, just continues and will continue. And, this whole push around natural refrigerants, around the industrial gases, as some people call carbon dioxide and ammonia and water and hydrocarbons, will continue to incrementally be used, or actually be, for example, ammonia is losing its place to carbon dioxide in some applications when you look at refrigeration. So, it's displacing naturals too. So this whole innovation just continues around hardware. It's not so much about the refrigerant. It's how the hardware and technologies and how you apply them and how you control them and the inefficiencies you can drive and the sustainability you can drive. So a refrigerant is like a steel, right? It's like, how are you going to use it? And what's the best thing you can use it? How do you make it as much efficient as possible and sustainable as possible? So that's how I look at it. I look at it as an engineering tool.
Thanks, guys. We got our next question. So are there any manufacturers working together or combining resources to decide what the best refrigerants are moving forward? Have they come to any decision, or are there any committees amongst manufacturers that are working on this? I guess we'll start with Phillip this time.
I'll say none that I'm aware of, but if it was, it would be under NDA. So even if I was, I wouldn't be able to speak to it because I'm not. I'll tell you unequivocally, I'm not aware of it. I know that early on, a bunch of manufacturers wanted to get together and try and come up with it, but no one seemed to be able to agree. So everyone decided to do their own thing. That's what I know. Steve?
Well, it's interesting. The marketplace decides, and people make decisions on cost, safety, and all that stuff. And as an industry, and this is a perfect example, this discussion, right? We're talking about this. People are building consensus. We go to ASHRAE meetings, we go to HRI meetings. We talk about technology. We present papers on technology applications and stuff. And so, you build consensus not at a individual level. It's as a community level. And ASHRAE is a great thing that allows us to talk about these things in a non-competitive space. And people can select a refrigerant, and enter the marketplace and see how it competes that meets regulatory requirements. So I don't see any of that happening. I just see a lot of competitors competing hard against each other with their solutions. The best mousetrap, right?
Thank you for that. So our next question is, do we have any concerns with refrigerant cost moving forward with many proprietary blends entering the marketplace and many, many new products needing to be on service technicians' trucks?
Yeah, that's always something that's brought up. Refrigerant cost always starts high and works its way down with higher use and volume, right? And production. Let's look at, and if it can be used in other industries, right? So let's take an example of 1233 ZDE. That's a common now foam blowing agent, and it is used in higher volumes there. And so the cost of that as it scales comes down. 1234 YF in cars started high, it's come down. I think since these molecules are more complex, they use more chlorine or fluorine or carbons, they're going to be more expensive. There's other factors too that affect cost of refrigerants. For example, a lot of the fluorospar, the fluorine HF, is in China. China has, shut that supply off or tuned that supply. There's been a lot of anti-dumping stuff that's driving up. I see one of them says, "Why is refrigerant so expensive in 2021?" Well, part of that is anti-dumping regulations, and so. A couple companies have won their case. The Chinese were dumping, and so prices come up for that. Of course, this whole pandemic drove up the price as well. There's a lot of different factors around that. But, the cost of refrigerants, if you look at the equipment, the cost of refrigerant is very minor. It's usually less than, depending on the equipment, large chillers, it's higher than this. Smaller equipment, it's less than this. And depends on the application, can be as low as 1% of the equipment cost to as high as like 20% of the equipment cost. So in a lot of equipment, it's really a small piece of that. And as we move forward and production gets higher and people innovate more, the price just comes down over time.
Thank you, Steve. Philip, anything to add on that?
Yeah, I'm just collecting my thoughts on it a little bit here.
Yeah, because it's a very complex issue. It's not straightforward. And then when we do these phase downs, it's going to be carbon based. And so what we saw in Europe was it was based on GWP of the refrigerant. And so you'll pay a lot more for a higher GWP refrigerant than a lower GWP refrigerant, or they'll price them really close to each other. And so it's really going to be interesting going forward from the economic standpoint of how the refrigerant suppliers are going to print as much money as they can. That's how I look at it. This whole transition is, how much the refrigerant suppliers how much money they can make and print in this whole game of keeping during this phase down of, I only have so much to sell and I only have so much GWP. Where do I price things and in the marketplace, and how much will the marketplace take? It'll be interesting. They played that game in Europe and it collapsed on them, a house of cards. So it'll be interesting to see what happens in the United States.
I'm just glad that Steve was the one who said that about the chemical producers, not me. Number one. Thank you. The second one is refrigerant costs. It definitely matters when you're selling into income groups that really don't have a lot of money. And if you're talking here in North America, there is a lot of that, but certainly more so in developing parts of the world where it really matters. So when you look at, if you keep the costs in the back of your mind, this was a spot check. You've got R410A sitting around $5 a pound. You have R32 sitting at less than that, at maybe $4 a pound. 454B sitting $13 a pound. And that's, yet 454B is what, 68.9% R32. And then they've blended in 1234YF, which is a more complex molecule to produce. So it costs more, and there's certainly less volume of it in production, even though I think all the major car manufacturers are now using it. And when you look at the cost to manufacture that molecule, there's no way it'll reach the cost point of something like R32. The only way you could offset that would be if some imbalance happened where somehow a tariff or other things got so big that they drove up a price of something that was only made somewhere else. Like they drove up the price. And Steve mentioned it too. The pure point of these allocations is to restrict supply. And it only picks on the HFCs. So these HFOs that have the double bond really aren't counted. It is simply the HFCs, and R32 is one of them. So R125, the other part of 410A, is one of them. Yet R32 is still the backbone for every replacement refrigerant that I'm aware of to replace 410A. So, and the idea too is you got to start using less and less and less of it. The second thing is, I think you mentioned service costs. So if I think manufacturer or certain techs anyways are accustomed to picking up different refrigerants from their supplier, probably distributor, and using them and then bringing refrigerants back to be reclaimed. And hopefully a lot of them are mixing the refrigerants and they're to be reclaimed, which is horrific because it's very expensive to separate them. But if you have a single component refrigerant that is much easier to reuse and to clean, in other words, it doesn't lose its composition. You don't have to test its composition if there's been a leak, because the compositions can change, which can change the performance of the equipment and maybe even the safety classifications. And then if you, with the allocations being reduced, one, if you stop leaks, two, if you recover the refrigerant, and we can set up a circular economy of reusing any refrigerant, even if it's a HFC, then that isn't counted in the allocations. So you need to find a way to reclaim that. And there are certain refrigerants have benefits in terms of the cost to the service tech, in terms of reclamation, to the building owner in terms of that. If you have a single component refrigerant as well, you can charge in both phases. Much easier when you're crawling in tight spaces and having to charge equipment, rather than, the cylinder having to be upside down like a 400 series refrigerant. So those costs come into play. And then there's also the third point is, let's not lose sight of total life cycle costs during operation. So there's the first cost, and then the operating cost of the equipment is really, really critical to whoever's paying for that operation. And really that's the play on what is the performance of that refrigerant. So if you can get a much better performing refrigerant that isn't necessarily the lowest GWP, you might still have a lot of savings over time. So those are the way I look at it. I break it up that way, upfront costs of the refrigerants. Is it manageable? Can you get it? Number two, what are the costs to go on servicing the equipment? And then even the total operating or life cycle costs over time.
So
Thank you both.
well, a couple rebuttal points. One is the safety classification of the refrigerant will never change. The 34 classification system is so conservative on our fractionation testing, it will never change the classification system. So that's just not a fair statement. The other thing is, we've been using 400 series refrigerants for the last 25 years.
Yep, 410A.
And, well, 404A, 410A, 407C, 407A, and refrigeration. So not just in the air conditioning marketplace, we're using refrigerants all over the place that have glides in them. So I just don't see that as a big issue. We're gonna have to deal with that glide going forward, and the refrigeration guys seem to be able to handle it.
410A doesn't have much glide. And how much are we
I know, but I'm
recycling?
not talking 410A, Phil. I'm talking about the other stuff
How much
that
is
we're
being
going to have to
reclaimed?
deal with. And so,
Virtually nothing is being reclaimed. In Japan,
and
they're
then
reclaiming 60% of their refrigerants. We're doing under
let's not talk Japan. Japan is not transitioning in the 404A marketplace at all.
No,
So they're still using half their equipment in 404A is in R22 still. So
they're not
they
even.
are
We
just
don't
not
reclaim refrigerants.
transitioning the way people think they should transition. They're still sitting on their hands with R22 in the 404A space, let alone the 410A space. And the third thing, believe it or not, in Europe, 454B in a lot of countries is cheaper than R32 because of taxes within that country. I'm not saying that we're going to have taxes in the US, but actually 454B, because its GWP is less, its tax on GWP is actually cheaper than R32 in Spain today. I believe in the Netherlands, and a couple other countries. Switzerland, I believe, is the other one. So, I
But
mean,
they're not using it.
yeah, well, people are buying products in Europe with 454B and R32 all over the place.
What,
So,
under 10,000?
because
How many units? Nothing.
no, there's lots. Trane selling lots of units. So we don't really sell any 410A left anymore this year. So people are
160
buying
million units in
people
the
are
world
buying the
operating right now.
sustainable
Can't be wrong.
solutions today. I expect people to buy sustainable solutions tomorrow. And it's not really, like I said earlier, it's not a discussion about the refrigerant. It's a discussion about what's the best product at the best price for the right customer at the right time.
That's right.
So
Yep.
I expect these solutions to be interim, and we're going to have to deal more with glide refrigerants. And, you know, I just had a service tech out to my house yesterday because my heat pump wasn't operating. And believe it or not, I don't think they could figure out how much refrigerant was in my unit. One guy said it was undercharged. The other guy said it was overcharged. I think they decided, they got up and just left at 5 o'clock. So I still think it's undercharged. But
Well, thank you both for that. So the next question we have is in regards to codes. So we're going to give this to Philip to start off with. Any indication on how codes might evolve to reflect different refrigerant characteristics, such as flammability?
Okay. When I hear
that's a
codes,
loaded
I
question.
think
That's a loaded
building
question.
codes.
That's a loaded question.
Yeah, this is the next question of the queue. Philip, you're up, sir.
All right. When I think codes, I think building codes. But when I think product and application standards, I think, I'm thinking standards. And I think those are definitely evolving. As more information comes in, Steve discussed the consensus process. And that happens not just at ASHRAE, but also in the international standards that are going on and being created and constantly evolving, both with industry support as well as stakeholders from representing, I'll say, other stakeholders on those particular committees. When it comes to the actual building codes, they have to then adopt the standards. And there's already been movement there. I think there's movement in 7 or 8 states already, where they've either adopted ASHRAE 15 on its own, or in my world, the air conditioning world, UL 60335-2-40. I think it's the 3rd generation that's on now, and they're in final reviews, I think, of the 4th generation. So there's 7 or 8 states that are already moving on that. I think we've seen California even though they're advancing the ball the fastest, I think, on HFC phase downs, they've only taken a little step in permitting the use of A2L refrigerants in small charge systems, window ACs, PTACs, dehumidifiers. So more like the small charge appliances. So they have not changed their codes yet, but they've basically said they're about to. So certainly there's a lot more states that need to start taking their time to, start enacting the new standards that have been developed. But I'll turn it over to Steve because you covered this quite well in your deck, I think, as well.
Yeah, building codes, go all the way down to the local level. Like in the city of Chicago Fire Department, right? They do things that the building codes consensus for the state might be different around, all kinds of different safety things, right? I expect, as we, like Phil mentioned, standards, right? 15, standard 15, standard 15.2, which is a unitary standard that's going to be coming out. UL standards 2-40, 2-89 will be adopted into building codes around the United States. The building codes will get updated. And I think it's going to be a 95-5 thing. People are just going to adopt those. People are going to work really closely. We're going to hit those dates of 2024 to get them all updated with the latest information around flammable refrigerants. Some people have gone early and adopted pieces, but I think from a momentum standpoint, EHRI, ASHRAE, the AIM Act requires states to update their codes to handle refrigerants. And so we're going to see this mass movement of all the states to these. You might have some local jurisdictional differences and stuff like that. You always get resistance to change, but I think by 2024, they're all going to be in place. It's going to take some learning, right? It's different, right? It's not, it's flammable refrigerants for dummies, right? It's not as straightforward as using a non-flammable where you just worry about A or B. Most things are A. If the B, it goes in the equipment room, it's not rocket science. And so I see this, in the next couple of years, just going to be a sea change. People are going to get training. They're going to get used to it. There's going to be a ton of questions, a ton of trainings going on. I know the Trane organization is creating a bunch of training around this and to get people familiar with how to handle the new building codes or the new processes in the building codes. And so I think eventually, TikTok 5 years from now, people will be going, oh, what was the big deal? And so I think we've done a great job on putting in the safety requirements and the product standards and then the application standards to hit the right safety requirements that we're used to having today.
Yeah, to Steve, to your point, that's kind of what's happened in 100 other countries. They're already using A2Ls, and you're not really seeing I'm not aware of any major issues. It's kind of a no-brainer. So I figure if third world countries and as well as Europe can figure it out, America can. Number two, if there are groups that want training today, there's already training being offered by ACCA, so acca.org, and then ESCO group, escogroup.org, so they're independent from us as manufacturers. And of course, we as manufacturers will bring out training when we have the need, when our teams need it, when our customers need it.
All right. The next question is going to go to Steve to start. What are some natural refrigerants that are being used, and can they be used for R134A equipment or other refrigerants being phased out?
Yeah, so I guess if you think about 134A equipment, 134A is used, in a plethora of different equipment from small. 134A was the refrigerant of use for portable refrigeration, devices you see in grocery stores, plug-in devices. That's all going to hydrocarbons, isobutane and propane. And so those are going to transition to that. So hydrocarbons, great refrigerants, more efficient than the fluorinated refrigerants, but their charges have to be heavily restricted because they're easy to ignite and they have a potential to create an explosion or a high pressure change, and so easy to burn and propagate. And so they're going to be kept to like 300 to 500 grams or about a pound of refrigerant. And so that application area is kind of small, right? And they won't really get out of that area, I think. Yeah, incrementally you might get a little bit more use out of them. When you look at the other natural refrigerants, CO2 is incrementally being adopted in refrigeration. CO2 is a great refrigerant if you can stay below its critical temperature, which is around 88 degrees Fahrenheit. And so it's great in low temp refrigeration applications, usually in a cascade cycle with some other refrigerant in the upper loop. It can be 134A, it can be ammonia, it can be a number of different refrigerants. When you look at ammonia, ammonia is used in the refrigeration marketplace as well, but there really isn't any natural refrigerant that's going to, where we're using 134A broadly today in chillers and large equipment, it just doesn't exist. Ammonia is a great refrigerant. The problem is it's the refrigerant plus the hardware that goes with it. Well, ammonia can't be used with copper. You can't do hermetic motors. It suffers from poor heat transfer because you can't make the enhancements on the tubes that you need to do because you can't use copper. And so even though it's an efficient refrigerant, it becomes less efficient because you can't enable the efficiency of the refrigerant. So I really don't see any natural refrigerants taking that bulk piece of the 134A chiller market. There's going to be great solutions, right? Like 1234ZE will be a good solution. YF, even though it's less efficient, will be a solution in some applications that you need to preserve the safety when you're using such a large charge of it.
Got it. Thank you. Philip, do you have any commentary on the natural refrigerants question?
Nothing further at all.
Okay. So the next question is, I guess this is kind of an interesting one. Will the phase downs or phase outs change under a different administration in the United States? Philip gets this one to start.
And full of opinions. All right, I'm going to say no or doubtful. I think under any administration, things can change, but the AIM Act was signed a year ago in December. And even though it had been written and documented and pushed by the U.S. Chamber of Commerce, our industry, like AHRI, a lot of environmental NGOs, it was still a surprise when it got signed on December 27th of 2020. So it was signed by the last president. The cool thing is it was intentionally set up as bipartisan. So the act was written by, jointly between a group of Republicans and Democrats. And I think when it was being brought forward, there was always, 1-to-1. And I'm not saying one person and one person, there may have been 14 and 14. So I think that was part of its success. And part of its success was that business was saying, let's do this. That being said, that's the legislation. What really happens is when the rules get written, and those are the regulations. So the AIM Act tells the EPA, you need to write regulations that meet this legislation. So they do have some bounds of interpretation of what they can do. So, and I think Steve covered this, their primary purpose is they have to reduce CO2 production and consumption. And by the way, consumption in the Act is not consumption by, say, a manufacturer or a user. Consumption, if I'm remembering this correctly, and Steve may know if I'm wrong, it's the producers of bulk refrigerants here in America, plus the importers of bulk refrigeration. So instead of saying 5 or 6 manufacturers, now you add in another, I don't know, a couple of dozen importers that are much, much smaller. They don't import that much, but they're still importing. And that's not within the equipment, it's bulk. Okay. Number 2, so they have to manage that. And then the second thing is it gave the EPA authority to take petitions, and Steve covered that really well. The petitions covering from at least the one from AHRI and AHAM, but there were others. But essentially, they have to act on those. So the fact is the EPA has a big role to play, and the EPA consults with all stakeholders, and everyone can put in petitions, and things could change. So ultimately, a new administration could come in and change people in and out of the EPA. That might tweak things a little bit, right? But they're still going to have to at least fall within the bounds of what the AIM Act tells them to do. I hope I explained that well. Steve, do you have any more to add?
Yeah, so the AIM Act has specific dates and times. It's very prescriptive.
That part
It
of
gives
it.
the EPA the authority to do what they're doing. The only thing a new administration could do, just like every administration, is they could slow the enforcement of it, get rid of people, don't add staff, slow things down, the rulemaking process. But in the end, they get sued by the industry, chemical suppliers and stuff like that, because they didn't meet the law and the intent of the law. So this is written in stone. It's going to happen. We changed to a Republican administration, let's say in 3 years. A little is going to happen. It's just going to continue because the ball is already rolling down the hill. And this is a good thing for the industry, a good thing for the environment, and a good thing for the manufacturers and job creation in the United States. And that is the main thing why the Republicans came on board, because this is a Job Creation Act or a Job Preservation Act more than anything else, because jobs are going to be outsourced if we didn't do the phase down. We have to buy products from overseas to do the phase down as refrigerants get eliminated right from production. So this is really, that's why the Republicans are on board. It's a American Manufacturing Innovation Act. That's the name. So
Thanks, Steve.
Yep.
Thank you both. Well, with that, we are out of questions, so we're going to do a little bit of Chris Berman Monday Night Football fastest 2 minutes with both of you for closing statements. Phillip, I guess we'll allow you to go first, sir. We'll give you 2 minutes on the clock, and then we'll give Steve 2 minutes, and then I guess I'll get 2 minutes to give my own opinion. I'm kidding. Phillip,
Yeah,
you're
I didn't know
first.
that there was going to be a 2-minute closing exercise. I'll say this: be excited, be interested, keep asking questions, keep being demanding for your customers. If your customers want performance, if they want efficiency, you're going to get there. What's interesting is, even though we have mildly flammable refrigerants, the fact is, at least a couple of these refrigerants are a hell of a lot more efficient than 410A. We've tested R32 in some of our inverter rooftops, and at the IER test points picked up to 12% more energy efficiency in the same equipment. And that's because you got rid of the fire retardant R125 that was impeding performance. So that's a real positive sign. I don't think you're going to see that in every single system, but what you're seeing is the ability to actually improve the environment and perhaps users' pocketbooks if the right refrigerants are chosen and used. And it can be a good thing long term. And I think that can be said for chillers. I think there's some options there for some pretty darn good performing refrigerants in our chillers as well. Whether it's scrolls, whether it's screws, whether it's some drifts. And I think expect more change. So stay nimble, stay smart. This is going to be something that we're working on, I think, definitely through 2036, which is the final date in the Kangali Amendment and in the AIM Act. But if I had to predict it, I would say we're still going to be looking at improved chemistry. We will learn more about these refrigerants that are being used today, and we will have to zig. And so stay on your toes, stay nimble, and be excited about it. I think this is good for the next generation of our kids that are out there in future generations. I don't know how
Excellent, Phillip. Thank you you're perfect on time. Thank you very much, Phillip. Great commentary. Steve, fastest 2 minutes.
Yeah, I'm a kind of a quiet guy. It's not very opinionated, so I don't have much to say. But
yeah, okay.
So we talked the last hour or so. We have a lot of solutions in place. This transition is going to be no brainer. The first half of this transition, we have locked and loaded solutions. They're available now in a lot of cases. Building codes are ready to go. It's not about the refrigerant anymore. What I'm excited about is electrification. Electrification of heating is a big one. I'm really excited about it because a lot of these solutions offer us the ability to do that over the old solutions from a sustainability standpoint. And people should get really excited about the future as we see the electrification of heating coming, as we improve the efficiency of devices. We're burning of fossil fuels, and we'll be using some of these next-gen refrigerants in these equipment that'll be GWP less than 10. These solutions are going to be, right off the shelf solutions, and we're going to be able to transition easy. You're going to see a ton of innovation driven around electrification, and these solutions will just be embedded into those. And as we improve our efficiency standards, you'll see these new refrigerants embedded in this, and we introduce new technologies and hardware around that, controls and better heat exchangers and better compressor technology and part load performance. And just the whole built environment is going to change how we use and apply HVAC equipment. I'm really excited about this. We're going to be reducing capacities on buildings. We're going to be, shifting loads. It's really going to be an exciting time. And the refrigerant stuff is just going to be in the background, I think, as we move forward, because I think we have the solutions and people can have confidence that their ultra low solutions are ready, above 200 tons and water cooled chillers. Those are long-term solutions. They're going to happen. There's some intermediate stuff, but we're going to have solutions, in the late 2030s and to solve those problems as well. But I think as we electrify, it's just going to create all kinds of different opportunities to innovate within the built environment. That it's just going to be things you're not even going to think of today. Within 4 years are just going to be upside down as the electrical grid and how we manage power and how we manage our electrical flow. It's just really going to be, it's really exciting time. I spend a lot of time thinking about that stuff rather than refrigerants, because it's like, yeah, we're going to solve this refrigerant thing is solved for most of the part. Let's move on, turn the next page, and start thinking about what the future is going to be like.
Excellent, Steve. Well, Steve, Phillip, thank you very, very much for both your expertise on the subject and for your commentary tonight. I think everyone gained a lot of knowledge and a lot of insight into both of what your companies are doing, both today and tomorrow. And with that, we are going to close. And thank you, everyone, for your time.
Thank you so much for inviting me.
Yeah. Thanks a lot, everyone.